Okay, so we are going to start it now. So thank you for joining us today for the CNES webinar challenges. So I'm going to make a little presentation of ActInSpace and everything, and then I will give the floor to the CNES expert that we have with us today. So please feel free to ask your question on the question box, and we will answer at the end of the session to every question that you will have. Thank you. So to start, so ActInSpace has been created in 2014, sorry, by CNES, and it's co-organized by ESA, and the CNES in ESA decided to give the operation part to Aerospace Valley. So since its creation, 35 startups have been created and are still supported by 16 international partners since the first edition. So the ActInSpace timeline, so it has been created in 2014, as I said before, but the first edition was just a French edition. So the international edition starts in 2016 with 12 countries, 24 cities, 900 participants, and 14 startups have been created. For the 2018 edition, 32 countries have been gathered, 55 cities, 2,200 participants were at this event, and 18 startups have been created. So for this edition, for the 2020 edition, you are almost 50 countries gathered, 90 cities, 400 participants. We hope that it's going to be it, and 35 startups should be created at the end of this session. So for the 2020 edition. So the ActInSpace goals. So during 24 hours, the teams come together to work on challenges based on technology or data from space, and even tomorrow, new services and innovation. But ActInSpace goals are also to dream and to become maybe a future entrepreneurs, to highlight the space sector and its daily impact, the contribution on the social economic growth and the startup creation also. It's also to create a cooperation between the space and non-space companies, and make patent licensing more accessible to all of the participants. So to talk about the patent, I just want to explain you quickly how the challenges were created. So the CNES had the space patent hidden away for a long time, and they decided to make them accessible to all of the participants of ActInSpace. So this idea was to develop the space and non-space sector companies, and Airbus just to join ActInSpace as a sponsor, and they decided to add and to contribute to the challenges with data, and that's how the challenges were created for ActInSpace. The real bonus of this event is then you will have access and the complete access to the CNES patent if your goal is to create or to develop a startup. So I now give the floor to Olivier Zephyr from the Luxembourg Space Agency. Thank you.
Hi, thank you. Very glad to have the opportunity to present currently the challenge from Luxembourg. So very happy to have the third participation in Luxembourg into ActInSpace. And of course, we thank first CNES and partners for currently hosting this event, because us ourselves in Luxembourg, we were able to mature our community into participating with this type of hackathon type of event. And this year we got a bit even more ambitious. My screen is popping up, so I think you're seeing the video right now. So the challenge we are presenting currently is what about to design a DIY configurator, do-it-yourself configurator for moonbots, design a lunar rover. What we want the teams currently, the mission and goal is going to be about, is to make the conception of the app to currently build a DIY lunar rover. So we want the team to think, if you had an app to build a lunar rover, how should it look like? Then throughout designing the application, you will yourself, the team will itself mock up a lunar rover with the mission to find ice on the moon. And of course, ending by designing a marketing flyer so as to make the world know that there is a lunar rover configurator that you can use to build your lunar rover. So I let the video ongoing. So the idea is to design that lunar rover. The challenge is supported by Space Robotic Research Group in Luxembourg. And the winning team currently will win the fact that they will receive the DIY kit, and they will be able currently to build their lunar robot and come to test it in a piece of moon that we have here in Luxembourg. So the winning team will receive the accommodation and the support to come to Luxembourg to test their DIY rover. So this challenge can be found currently the video on the Luxembourgish site page on the ActInSpace. And you can also in the challenge area see the challenge itself. If I'm just going back to the challenge on the other page, here you go. So as I mentioned, we are a consortia in Luxembourg with the Luxembourg Space Agency, the University of Luxembourg, me myself from a tech incubator with Space Focus, and InTech, which is our technology and innovation partner. So what we want participants within this challenge to operate, as I mentioned before, is to create and conceptualize an application to configure how to build moon rovers. How this idea came to us, it came to us given the fact that bits and pieces of electronics, you can buy it online everywhere. If you want to build a DIY rover today, you can find the motion system, all the different sensors, the infrastructure of the robot. You can find all these bits and pieces on internet. But what you cannot do is currently check if the configuration is right to operate. So this is what the app is meant for, building that app to check that the configuration is correct. So what we will simulate with participants, you will build a conceptualized application. We will check in Luxembourg within our team HQ that your configuration is correct. Then you will be able currently to specify how you will operate the mission, which is currently to find ice on the moon. So you have to configure the right sensors to find ice on the moon, and then to design the product marketing flyer. So we will give you the specifications to do so, the basic specification that you should put into the configurator, and also upon which you should build your DIY kit. So the idea is really to simulate. There are already existing tools online to play, but not to do real gaming. You have Kerbal Space System, not to give names. It's a serious game, but you can find on different platforms today. So we are simulating such serious gaming environment. But the point here is that the winning team, with its configured DIY moonbot, will be able to come and test their rovers in the real physical environment here in Luxembourg. What we have in Luxembourg is 80 meters square of moon surface reproduction, where we can really test how do your robot behave. So I'm looking forward to your question, if I can be clearer about what it is. So you can find the description of the challenge as the video, the description of the challenge in the ActInSpace challenge area, and the video that I just showcased, you can find it on the Luxembourg site on the ActInSpace platform. Thank you.
Okay, thank you. We are now going through.
So we are now going to give the control to Damien.
Hello.
Okay, Damien, you have the.
Okay. Hello, I'm Damien Chilo. I work for the CNES and I will present the challenge, What can you do with all that snow? For that, I leave you with a video of myself presenting the challenge to you. Where is the video?
So we put it now.
Okay. Welcome. What can you do with all that snow? Earth observation satellites monitor ocean, atmosphere, geology, and continental surface. They are all studies in CNES by the Terra Hub. TEIA is the hub of continental surface. Since 2015, TEIA developed a product to indicate absence or presence of snow every 5 days. Products are based on Sentinel-2 and Landsat-8. Two products are available. First, we have a monotemporal present in many places on the planet. It shows the presence of snow at a specific time. Second is the annual synthesis, only present on Pyrenees and Alps. It shows the time during which the surface was covered. That data can be used for winter sport results, environmental prediction, water resources, animal ecology, farming, and anything we can imagine. Now I show you how you can access the product. First, you go on TEIA website. You put in English, click on Data and Products, TEIA thematic product. You go on continental hydrology, snow, of course. Here you have monotemporal product and here yearly snow data. First, you go on monotemporal product. To download, you should sign up. We choose a date with snow, for example, November 1st, November to February. Okay. You can type your place or trace a zone of interest. For example, trace a zone on Pyrenees. And church. The different images appear on the map with most precision here. We choose one on February, for example, that one. We can see different information. The date, the satellite, Landsat 8, snow cover 40% of image, and cloud cover 1% of image. You can download here. The folder contains 2 files with interest. First, raster with 4 categories of pixels. In other words, with 4 colors. First category with no data, another for cloud, of course one for snow, and the last for no snow. We have the second, the shapefile, and vector image with 2 shapes, one for snow and one for cloud. Open the first with QGIS. For easy viewing, you can colorize this image. Teia provides on her site a style file for QGIS. Here. In this site, we have all treatment channel of snow product. Download the style product and apply on the image. Let it snow is the name of treatment channel. Style raster QGIS 3.4 for me, and apply, and you see in blue snow, in gray no snow, and in white cloud. Now we can add the vector file in shapefile. And you can colorize them with other style file. Here, vector QGIS. Apply. OK. And we have in blue snow, and in white we don't see, of course, cloud, but you can colorize them, for example, in red cloud, and in blue snow. Okay, that is the first product, the monotemporal. Now we have the second product who presented the annual synthesis. Here you have one product for one hydrological year from 1st September to 31 August. One per year since 2016. I download the last. The product presents a mosaic of images who cover Alps and Pyrenees. You can put on QGIS or mosaic. Okay, Alps and Pyrenees. On this product, every pixel is coded from 0 to 365. 0 is never snow, and 365 is always snow covered. We can put a little color, for example, a gradient black, blue, white. Black is 0 days of cover, and white is always covered with snow. Apply, OK, and we can apply with all image, all mosaic. Ta-da! And we can see in white here, for example, a place with snow every day. Thank you for your attention, and I even invite you to visit the snow project and all the Teia data. I leave you with the snow in the Alps. Thank you.
Thank you so much for the explanation. And now we are going to talk about the other challenges of the CNES with Mr. Walter Dieudonné.
Hi everyone, my name is Walter Dieudonné, and I'll present you the CNES challenge from 1 to 9. I'll try to be concise because there are a lot of things to talk about, and please write down questions if you have any. and I'll try to answer them at the end of the talk. Okay, so let's start with the first one. So the first challenge is called get antennas tattooed. So basically, this is about compact. So this is one of the keywords, compact antennas on soft membranes. So another keyword is membranes. Basically, CNES has developed a solution with patterns that are engraved onto soft membranes. So basically, on the membrane, you have no electronic parts. You just have reflector arrays. And this is a very nice solution because it's very compact, it's lightweight, and it simplifies quite a lot the reflector array part of antenna design. So basically what we are proposing is a challenge based on this technology, and this is currently done for space, but this can easily be extended to Earth applications. Some of the keywords are that this is simple, this is portable, lightweight. Therefore, you can think about using this technology on rough and tough conditions, such as environmental disasters or humanitarian emergencies. I'll show you a picture with this technology so that you can understand better, maybe. Okay. So here, okay, too fast. Here you have a simple picture, a schematic, showing a satellite. So the satellite is the little rectangular platform in the middle of the picture. And around this satellite, you have a polygonal membrane. And on this membrane, you see that we have about 8 reflector arrays, circular ones, square ones, ellipses, hexagons. And on either side, you have solar panels. So what you see is that with this technology, you can deploy large size panels. And one of the reason why this was thought of is because the accommodation within the launcher canopy is a lot easier than with regular antennas. So for Earth applications, this is to be kept in mind as well. Okay. So this is well adapted to large structures, and you have a pretty big mass reduction. And the cost that's important, essential part actually. The cost for this kind of technology, they're quite reduced compared to regular antennas. Second challenge from CNES. So challenge number 2 is images with attitudes. Okay, so let me open it up. Images. Okay. So for this challenge, the idea is to have an accurate representation of the orientation of the data acquisition system. This is very important to know the proper data acquisition system orientation to be able to get back to information such as medium and high frequencies, micro vibrations. These vibrations, they perturb the images, and this is especially true when you're going to very high resolution pictures. So basically what CNES did was to develop a system that takes a set of images at different time intervals, and by doing some integration, you can get back to the vibrations information. So this was created for satellites on the first hand, but this can be easily extended to other airborne systems. So you can think about drones or any flying piece of equipment. What you can propose with this technology is basically you can get rid of vibrations, and therefore you can obtain much better and higher quality for the images you're going to acquire. So the picture is not very self-explanatory. Oh, too fast. Okay. Okay, picture please. Ah, come on. Picture. Okay. So this picture basically just show you a the mechanics of the invention. Much more information can be obtained in the actual published paper. So this really gives you unprecedented accuracy, really, on the attitude resolution restitution of the data acquisition system. So this is what you should retain. Next challenge is CNES challenge number 3. This one is titled Load Up with Geometric Patterns. Basically, with this one, you optimize your antenna with you optimize the reflector arrays with imbricated patterns. So you have patterns that are engraved one within the other one. So this really has a lot of advantages with this technique. So first I'll show you a picture. If I okay. So this is a picture. Oh, very sensitive. Oh, let's try again. So this is a picture basically where you see different patterns that are really one within the other one. So this has, as I said, many advantages. You can really cover a wide band. So this is like several decades. So this is important because you are going to have a wide radiation. This is a very robust system, actually. This is robust in the sense that this is very resilient to external perturbations or parasites. So with this system, you can really get really good communication and good data rates. And one other key element is that this is not very complex in the sense that you don't have really any mechanism, and therefore it's going to be a lightweight system. So all of this is very interesting because this is really an optimal approach to antennas. Therefore, this, for example, you can have many applications in many fields. So this, you find this in the challenge number 3. It's compact, it's light, it's simple. All of this makes a very good candidate for reflector arrays, and Earth applications can be very wide. Next challenge is CNES number 4. It's entitled Widen Your Vision. So the idea is to have a very simple optical instrument that enhances the field of view. So the key element in this invention is to have if I can get, oh, sorry, I didn't show you the challenge. Okay, here is the challenge. So as I said, widen your vision. So the idea is to have a very simple optical instrument with basically a rotating prism near the entry pupil. With this, you're getting a system that can be adapted, and it's again quite simple. And you have a continuous rotation. This is very stable, and this is a lot more tolerant to faults than typical scan mirrors. The system parameters, they can be adjusted. So basically what you can adjust here are the rotation speed, the integration time, the number and the geometry of the detection lines. So what you get is a system that is, for example, very well suited to ground surveillance. It's simple, it's lightweight, and it's flexible. And because of this simplicity, it's going to be a lot less costly than equivalent optical systems. Next one is challenge number 5, which is entitled See the Invisible. This challenge is very interesting, especially right now, because it's a one more time, it's a simple system, it's autonomous, it's laser-based, and you can do real-time contaminant detection. Basically, with this, you have a bidirectional scanning system that look at a plate, simple plate with a set of diodes, and you can get information about particles that you have on this plate. The applications, they're very wide actually. You can think about white rooms, hospital for contaminant issues. You can think about pollution. And because of the system's simplicity, portability, this is very well suited to field applications. So this could be used really on remote places where it's difficult to get there, where mass and size does matter. The way it works is as presented in this picture. So basically, you have a plate. And on that plate, you have on either side, you have the detection system. So this really allows you to get information about the particles. For example, the diameters. It can be between 1 and 20 micrometer. So you're really going to small particles. So this is very interesting. This does real-time monitoring. So you get real-time information about how much particles you get. So the number of particles, their size, their form factor. So this really gives you a lot of information about the environment and the way it can be contaminated. It is, because of its simplicity, it's simple to power, so it can be transported. And this can also be placed within a network of sensors. Therefore, you can do some very nice automation. And that's it about this challenge. So as of today, this has a lot of potential applications. Now we go on to the next one, and it's going to be challenge number 7. Challenge number 7. No, sorry, challenge number 6. Challenge number 6 is, the title is origami or satellite dish. So this is about deployable structures, deployable reflector arrays that are close to parabolic shape once they are deployed. It's pretty much like origamis. So the idea is to get a set of panels, very simple shaped panels. You have squares and triangles, and they can be folded on top of each other. So once it's folded, it's very compact. So for space applications, this was a key element, compactness. And once you unfold it with very simple mechanism, once you unfold it, you get a very nicely shaped parabolic antenna. So this is easily extendable to many Earth applications. For example, the SATCOM vehicles, or on-the-go vehicles. So basically, for telecommunications, you're gonna get a very robust, a very simple system, and it's not costly because of its simplicity. The mechanisms are very robust, and it's actually light. Your system can be either manual or electric, but because of the simplicity and the fact that it can be manual, then you can think of this system being, for example, transported in a backpack and being easily developed on the field of operations. So I'm showing you a picture of how it looks. So in the example, you have a set of nine panels, so 4 triangles and 5 square. And once they're assembled, they form a really nice array, reflector array. So that's pretty much it for this challenge. Now we're going to the next one, and it's challenge 7. Challenge 7 talks about environmental and hydrological variations. So with this technology that CNES developed, you're getting a very accurate representation of the contours and the altitude of water areas, but small water areas such as artificial lakes or natural lakes. So for dams, rivers, seashores, coastal areas. Right now, we're getting a really accurate altitude estimation for large water areas such as seas and oceans. But once you get too close to borders, coastal borders, then the accuracy really gets down. So what this invention proposes is to get a really good accuracy. So you can have applications such as following climate changes. You can follow dam securities. Well, the implications and the applications are really many for this. I'll show you now a picture that will give you some indication. So one of the important point is that this invention does not require any change on board satellites. The idea is to have a ground receiver. You see it on the picture where my mouse cursor is. You have a ground receiver, and with this, you can really get the proper contours and altitudes for restrained water surfaces and near coastal areas. Ooh. Okay. The challenge number 8 from CNES is spontaneous foldable structures. Okay. So this CNES is working quite a lot in the areas of deployable structures. This is a lot of work and a lot of activities is going on this, because this is key for a lot of applications, well, a lot of space applications right now, such as mass deployments, or even for remote exploration for rovers, for deploying mass, for any deployable structure. So the fields of applications, they're very wide. So the idea here is to use a set of collapsible structures that are based on really soft composite panels. So you have a pantograph. So pantograph is some kind of wireframe around these panels, and basically that guides the direction towards which it's going to deploy. And with this system, once you deploy your structure, it's because of elastic properties, it spontaneously deploys, and once it's deployed, it locks in. So you have some we call a box effect. So it locks in into a very robust and stable shape. So it's robust to bending, tearing, and shearing. Because of the way it's folded, you're getting something that is very compact. Because it's made of composite, soft composite material, it's very lightweight. So these are good qualities. This technology can be really readily applied to Earth applications. If you need, this can be seen, if you want, as some replacements of inflatable structures, or even you can think of hybrid use of this kind of composite deployable structures and inflatable structures. So on Earth, we give you some indications that you can think of field medical centers that needs to be deployed simply and rapidly on tough environments. You can think of temporary shelters. Basically, every time you need some to deploy some rigid structures, you can use this kind of method. I'll show you a simple picture. Here it is. So what you see on this picture is the folded system, the system that is deployed, and you see the wireframe, the pantograph for the deployment. What I did not mention is the inside of the structure is hollow. So that's one of the property of this system. Being hollow gives you this really nice box effect, and is really light as well, lightweight. Obviously, in this system, you see that there is no engine or no electric device or anything. This is really a purely manual system. Now we're going to the next challenge, which is challenge number 9, and it's the last one I'll present. Challenge number 9 is called In Great Shape. Great shape because it's really about pedestrian tracking. Today, it's extremely popular to have smartwatches or portable devices with sensors and GPS. And when you go out hiking, biking, or whatever, you're getting information about what you're doing, how you're doing it, and it's very popular, and there is a really wide market about it. What CNES did was they developed a purely software-based solution that actually uses the existing sensors, and it improves from the existing sensors. It improves the accuracy of the measurements. So this can be, and that's very important, this can be applied to all existing hardware. So it's really a software update. The idea behind this is basically they use a state vector for the speed and the altitude, and with this information they can filter out parasites and they can get better measurements from the sensor, and at the end of the day you will get more accurate representation of your speed, your altitude, and all the data related to that. So the array of application is tremendous. As we wrote, it can be fitness trackers, smartwatches, smartphones, and you can even think of new sensors and new devices, some portable devices, whatever. This is really open. This is really up to you. So the picture, the picture is not really does not really show any more information. It just shows a pedestrian walking, and with this technology you can really follow properly the location in 3D space. So that's pretty much all I had to say about these nine challenges. Sorry if I was really fast. I'll try to be concise. If you have questions, I will be very glad to answer them at the end. So now I'll give back the talk to the presenter. Thank you.
Okay, thank you so much for all this explanation and for these exciting challenges. So now we are going to pass to the Q&A part, and I will let we will ask you all the questions, and you will answer to this. So please feel free to ask all your questions, and we will answer during the session. Thank you. So don't hesitate to ask your question. Okay, so for now, we just have a little remark, not a question, but it will be more efficient to create an API, and then expose data through the API, then use the images with libs as OpenCV or other libs.
Don't hesitate if you have other questions to ask. It's here for that.
So we have one question, sorry. What will be shared to the participant in Challenge 8? Does it include fabrication? No, how? So I think it's for you, Walter.
Okay, so Challenge 8 was about the spontaneous foldable structures. so the soft panels that shape into some really nice rigid structures. So the question is, what is shared in terms of fabrication, right?
Yes.
Yeah. Okay. So
yes, I
okay.
can read you if you want it.
Okay.
What will be shared to the participant in Challenge 8? Does it include fabrication know-how?
The fabrication know-how. Well, what I would say is simply, in terms of fabrication know-how, for the challenge, you don't really need to know exactly how it's basically built. Though the fabrication is actually not very difficult. If you know how to manufacture soft composite panels, and I think this is a pretty well mastered area. You can basically manufacture the item. What we expect from the challenge really is, with this technology in mind, really find applications. So as I said, for example, think of a system which is a hybrid system between some inflatable sections and this as stiffeners, for example, and you can really deploy super fast a filmical center. So that's what we expect from the challenge. The way it's fabricated right now that's not really the relevant point at the moment. It will be later on, even though this is not, there is nothing difficult about it. This is not going to be a showstopper, this fabrication issue, okay?
All right, do you have any more questions to ask?
Thank you so much, Walter, to answer these questions.
Okay. Thanks for the great presentation, but I have a problem understanding Challenge 8. Please, could you explain further?
Okay. Okay, Challenge 8, what we propose is CNES develop a methodology for deploying what they had in mind was deployable mast, for example. A mast on a rover, okay, or a mast in space on which you're going to put, I don't know, solar arrays, for example. So the idea was to have a system which was very simple, which did not require any power, and you have a structure, and it's made of, as I said, hollow. It's a hollow structure, so it's a tubular structure. So you have tubular sections, and each section, each panel, each section is connected to the other one with a simple hinge. Okay, and all this structure is bent and using elasticity, and it's compacted and bent using elasticity. Then you get a wire frame on the around it. We call it a pantograph, so that we can properly set the direction in which it's going to unfold, deploy. So if you look at it from the front, if you look at the panels from the front, you have a hollow structure, and you basically have two convex arcs. You have two convex arcs that face one another. Okay, and this is, from a mechanical standpoint, this is very simple. So all it relies on is the elastic properties and the hinges, so that you deploy a tubular a tubular frame spontaneously. I hope this answers the question.
Okay, thank you.
Thank you so much. So we have another question. Due to COVID-19 situation, do we have to be physically present during the hackathon, or it will be done all remotely? So to answer your question, it depends of the city where you're living and the country also. So you will have all these information. So I invite you to go to your local page and to see if the event is going to be remotely, so a virtual event, or a physical event, depend of the countries and all the restrictions that they have. Thank you for this question. So we have another question. This one is not for us, I think. Currently, there are competitors providing similar extendable booms in the market. Oxford Space System Astrotube boom. How does current state of the art and current market affect the judging of ideas for the project 8, for the 8 challenges?
Okay. Well, this is not. It's not really too technical. It's more about the economical placement of this. There are indeed well, deployable structures. They're very popular. There are many actors on the market, and there are many technologies. Basically, they all have their strong points. They all have their advantages. What you are, it's part of the work you have to do. Actually, it's you have to see compared to other offers and other technologies. You have to make sure that using the technology proposed by CNES, that this actually gives you an edge in terms of an economical edge. So, well, the points of this technology is compared to other, the strong point I would say is that it's okay. Of course, they're all compact because they're deployable. This one is really simple. It's one of the simplest solutions because you only rely on the elastic energy that is stored into this tubular shape when you fold it. This is the only requirement that you have. So this is making it extremely robust. So this system, whenever you need something that is very safe, whenever you need something that needs to be operated in super tough conditions, so disasters or whatever, operated by very few people, because you don't need to be 10 to actually set it up. Just release the mechanism and it will pretty much pop up. So it's really your work. It's up to you to weight what the economical market. So what makes this more viable, or what makes this this technology more suited or better suited actually than another one. So actually, it's really your work. It's not to see exactly how to manufacture the composite panels. This is not really what you're being asked. Your work is really to see that this can be more efficient, this can be less costly, and this can be a really good product to sell. That's pretty much it.
This is Guillaume Prigent speaking from CNES. Thank you, Walter, for this added value of the project. One thing is, if you want to participate to ActInSpace, you have to work also on space technology. So that might be other technologies similar to this one, but this one is for sure coming from space. And at the end of ActInSpace, you have to pitch a project of a startup using space-based technology. So this is also why this is something interesting. And the last thing is if you want to continue after ActInSpace, even if you don't win, and this is very important, CNES will be able to help you and to provide you support from a space expert to include this technology. And it's possible that you will improve the technology. We will be happy to hear about it and to collaborate with you after that.
Okay, thank you so much, both of you. Walter, did you have something to add?
No.
Okay, then we have two questions. Guillaume, maybe you can answer these questions. Is it possible to form teams in between cities, countries? Sorry, so that is not related to the CNES challenges. And another question to continue, is there any limited age to participate in ActInSpace contest? And are the kids involved? So I let you answer.
So the first question, yes, it's not possible to mix the team between different countries. One maybe way to proceed is to find in your country a city that organizes ActInSpace virtually. This way you can log into the city. I take the example of France. If Paris organizes ActInSpace virtually, if you're not from Paris, you're from Marseille or whatever, you can join this city. So this is a way to collaborate within your own country, but yet it's not planned to open the creation of teams between different countries for one reason, because we would like the startup to be created, to be helped by the local ecosystem. This is important. So this is why we would like the teams to be created at least in the same country. So this is the first point. The other point, the second question, Mathilde, can you recall me the question, please?
Yes. Is there any limited age to participate in the ActInSpace contest, and are kids involved?
Okay. No, there's no limits in terms of age. Just you have to be over 18, just for I would say security reasons and a question of responsibility. But there is no limit in age. We are looking for different profile, background. You don't have to have a little bit of knowledge in science or in space technology. That will be perfectly fine. What we are seeking is people that have a precise idea of the challenge that has to be solved in an environment, health, or whatever. And our work is to bring you the access to space technology.
Thank you so much, Guillaume, for these answers. So we don't have any question for now. So just to add some information, the next webinar is going to be next Thursday. So with the CLS and CNES challenges, so they will be present their challenges. To contact us, you have our email address on the left. And you will be also able to see the replay of this webinar on the Connect by CNES YouTube channel. So the first one with Airbus is already available, and the CNES webinar will be available next week. Thank you. So thanks. Oh, perfect. Thanks a lot. So another question, Guillaume. Small follow-up in that case, if we register to a city, is it possible to change to Paris then?
I think it's possible, yes, to change. Just have to see what we have to do technically. I think, Mathilde, you can look about this, but I think there's no problem at all to do this.
Yes, you just have to delete your account and create a new one in the new city where you want to register. So here it's Paris, and then you just have to delete this account and create a new one. Okay, then we hope that we answer all your questions. So thank you so much for being with us today. So thank you to all the CNES experts to explain all these challenges with many patience and many skills. So hope to see you for the next webinar, and have a good day. Thank you so much. Bye-bye.